Hi, in this video we're going to look at the topic of sequences, which is both a higher and foundation GCSE topic. As ever, if you want to ask any questions about this, you can contact me at Mr_G_Walton on Twitter, or you can follow our maths account at Tupton Maths. So what we're going to do in this video is we're going to look at the following things. We're going to look at being able to calculate different terms in a sequence, and a term is a number that's in a sequence. Okay, so the proper mathematical word for that is a term. We're going to find something called the nth term, and that's just a general rule for a given sequence. And finally, we might also look at to see whether a particular number is in that sequence or not, and show you some ways that we might be able to do that. These sequences could be both numbers and patterns, and we'll do a combination of those. And I might even challenge you towards the end with a particularly nasty looking one that might challenge the higher pupils too. Okay, let's have a look at in terms of what a sequence is. So a sequence is just a list of numbers that have a rule that determines how the next number is going to be found. This question says, here is a rule. So it's actually telling us the rule straight away. Multiply the previous number by 2 and then subtract 1. Okay, fair enough. The first term of the sequence is 3. Work out the next 4 terms. Okay, so first number was 3. How are we going to work out the next ones? Well, the next ones we said we had to times by 2 and take 1. So 3 times 2 is 6, take 1 is 5. The next one, 5 multiplied by 2 is 10, and then take 1, which is 9. And the next one, 9 multiplied by 2 is 18, take 1 is 17. And finally, 17 multiplied by 2 is 34, take 1 is 33. Okay, so we've got this sequence. It doesn't ask us to do anything else, just work out the next 4 terms. So we've done. Excellent. This is the nicest type of question that you can get, where it tells you the rule and asks you something to do with it. In this example though, it tells us that the nth term of a number sequence is given by 6n minus 1. Now this is also a rule. It's slightly different to the last one, in so much that this one contains some algebra now. So here, before it said multiply the previous term by 2 and take 1. This one, it says 6 multiplied by n, take 1. Now, it would be really useful if we knew what n was, but we don't. So let's think about how we can have a go at working this out. If I say that n is the number of the term, then n could be 1 for the first term, 2 for the second term, 3 for the third term, 4 for the fourth term, 5 for the fifth term, and so on and so on and so on. So let's think about how we're going to work this out then. Well, the rule that we've been given is 6n minus 1. And you'll know from your algebra skills that this means to substitute the value when n is 1 into here and see what number we get. So if I do 6 times 1, because in this case n is 1, 6 times 1 is 6, take 1 is 5. So the first number in my sequence is 5. The next number, well, let's see what happens there. Well, that's when n is 2. So n is 2 here, so we're going to substitute 2 in for n. So 6 multiplied by 2 is 12, take 1 is 11. The next term is when n is going to be 3. So 6 multiplied by 3 is 18, subtract 1 is 17. That's the third term. And I could keep going like this, so on and so on. So it's asked us to write down the first 3 terms of the sequence. We have. Just out of interest, let's at this point see if we could work out whether, let me make up a number, and I genuinely am making this number up now. Let's see if 52 is in this sequence. So I'm now asking an extra question, is 52 in this sequence? Okay, how might we go about working this out then? Well, if 52 was in the sequence, then if I did 6n minus 1, I'd want 52 to be an answer. So 6n minus 1 is 52, equals 52. Now, this can only work if n is a whole number. Notice here that n was 1, 2, 3, 4, 5, 6, 7, and so on. We never had 1.2 or 6.5 or anything like that. So let's see if this is going to work. Let's think about how we're going to use our algebra. So hopefully you know that if I've got a subtract 1 on this side, I need to add 1 to both sides. So I get 6n. If I add 1 to this side, I've got add 1 to this side. Minus 1 plus 1 is nothing. So I've just got my equal sign now. And adding 1 to the other side gives me 53. Now, the question now is 6 times something is 53. Well, 53 isn't in my 6 times table. So n isn't a whole number, and another word for whole number is integer. So we can say isn't an integer. You could of course write whole number. So therefore 52 is not in the sequence, and I can be quite confident about that. Okay, let's look at another example. In this example, it tells us the first 4 terms of a sequence, and then it asks us to write down the expression for the nth term. So this is like the reverse of what we were doing before. With this sort of question, I always do the same thing, and I ask you to do the same thing as well. If you look at these numbers, is there something in common that it's going up in? Now, for foundation pupils, this will always be going up in a fixed kind of number if you're being asked for the nth term. For high pupils, you might also want to check out another video that I'm going to make, which is about quadratic sequences. But for this one, this is going to be a linear sequence. All that means is that the number's going to go up by the same each time. So in this case, it's going up by 7, positive 7. 7, 7. So because it's going up in sevens, the first thing I'm going to write down is 7n. Each time 7 is being multiplied by the number. Okay, so whatever number is in the sequence, it's going up in 7, so multiplying by 7. Now, that's all well and good, but if my first term is when n is 1, we've just learnt that from the last slide. If I did 7 times 1, I don't get 4, which is what is showing here. In fact, what I've got, 7 times 1 is 7. No, that's no use to me. So I'm going to have to do something to adjust this to make it be 4. So instead of 7 times 1 equaling 7, I want it to equal 4. So what I've got to do is take 3 away. And that's it. I've now found the nth term for this sequence, 7n minus 3. Now, an extra question that we might ask at this point is, and calculate a particular term of the sequence. So I'm going to see if we can calculate the 10th term of the sequence. Okay, so if you want to have a think about that, the 10th term of this sequence, how might you go about it? I'm hoping that you've already got an answer now in your head before I tell you. So what we'd do if it was the 10th term, n would be 10. So we're going to use our algebra rules again and say if n is 10 using this rule, we've got 7 multiplied by 10, take 3. 7 times 10 is 70 minus 3, which is 67. So the 10th term in this sequence is 67. Okay, here are 2 questions. The first question I would like everybody to have a go at. So pause the video and have a go. It's asking for the nth term of the sequence. Part B is a little bit more tricky. So I want you to have a think about it. If you want to have a go, then by all means. Higher pupils, definitely have a go. And use some sense. Use some of your common sense. Use some of that kind of intuition that you're starting to build up by now. And write down what you think might be sensible. Definitely do part A first, and then look at part B. So pause the video now. Have a go. Okay, so by now I'm hoping that you've done part A and you might have had a go at part B. Let's look at part A. Part A goes up by the same number each time. We can see it goes up in 4s, so we're going to write down 4n. The first number in the sequence is 3. if I did 4 times 1, I'd get 4. I don't want that, so take 1 away. That's my nth term. Now, part B looks similar. I've got the same numbers on the bottom. I've got 3, 7, 11, 15. Oh, well, that was the same. But I've got another number on the top. Let's see if we can do something with this. The first term is 1 over 3. The second term is 2 over 7. The third term is 3 over 11. The nth term. Let's see if we can go straight into this. The nth term. Well, we worked out in part A that the number at the bottom, we can have a rule, which was 4n minus 1. Okay, so 4n minus 1 there. What's the number on the top? Can we see a link between the number on the top and the number in the term? Well, we can. It's exactly the same. It's n. So in this case, the nth term rule for this would be n over 4n minus 1. If you got that, really well done, because this isn't a very standard question, but it's not particularly difficult in terms of the working out. It just needs a bit of confidence, really, in terms of spotting this pattern and thinking, do you know what, I've not seen one like this before in class, but it doesn't matter, I think it's right. And in this case, it has been. Okay, in this example we can see it says James has drawn this sequence of rectangles. What I'd like us to do is to see if we can work out what the nth term is for the pattern showing the width. So that's the width here. Okay, so we're interested in the width. Pause the video, see if you can spot a pattern for the nth term of the width. A quick clue for you, this one we could call pattern number 1, this one we could call pattern number 2, and this one pattern number 3, or rectangle number 3. Okay, give it a go again if you're not sure. Okay, so let's see, we've got n is, or pattern number is 1, 2, 3. The widths of those were 2, 3, and 4. Do we spot a relationship between them? Well, yes we do. Each one's been added 1 on each time, so the nth term is n plus 1. It's just 1 more than the sequence number of this rectangle. Okay, hopefully you got that one too. A little bit abstract, but not a particularly difficult answer, but sometimes picking out these easier answers from what looks like a difficult question is a really good skill to have. Okay, so at the end of this video, as with all the videos, I make some revision card notes. This is a topic on sequences. You might want to draw yourself out a quick sequence and you can make one up. You might go, I don't know, 6, let's see, 6, what about 13? So I've decided to add 7 on this time, 20, 27, etc. You might decide to write down what the nth term is. So nth term, and how you would work it out. And remember, what we're doing is looking for the pattern. What's it going up in each time? In this case it was going up in 7s, so we write down 7n. And what do I need to do to get from 7 to 6? I multiply 1. So this one has got the pattern nth term sequence 7n minus 1. Okay, if it's an actual pattern, it might be dots, it could be matchsticks, it could be anything like that. Write down what the number is in the sequence, and if there's more than one thing, read the question carefully, then write down the numbers. And if you're asked to work out what the, I don't know, 20th term of this sequence is, so 20th term, we're going to use our algebra skills and substitute 20 in for when it says n. In this case you do 7 times 20, which is 140, take 1, which is 139. Okay, as ever, good luck with your exams. I hope you're finding these videos useful. If you need to ask anything, you can always do so on Twitter, and I look forward to seeing you soon in revision. Or if you're online, then keep asking questions, and good luck. Bye!